This video, we'll be demonstrating a new feature on our Titan product line. It performs a closed loop servo using a Hall sensor only. Normally for a closed loop servo, you have a more use an encoder feedback from the motor to the controller to perform a little higher accuracy. In this case, we'll be using only a Hall sensor to perform that feedback. The setup we have here, we have a Titan SVX ETH. It is communicating to a PC through a USB communication. We also have a unique motor here. It's called a drum motor, very useful for conveyor applications. It is a 3-phase brushless motor, which is connected to the Titan SVX ETH. It also has a Hall sensor feeding back as well. So to start off here, we'll open the Titan SVX ETH software. I'll go to the communication page and check communication just to make sure everything is working. Next, we'll go to the motor window to get everything set up. The easiest way to do that would be through the MDB wizard. The MDB wizard will perform some motion on the motor, so just make sure you're prepared for that. So the first thing I want to do is select the type of motor. For here, we have a 3-phase rotary brushless servo motor that we'll be using. We'll go ahead and name that motor. We're using 24 volts in this case, and we'll use a 3-amp motor here. You can also manually turn the motor shaft, and you can see the Hall sensor indicators change as you turn the motor. And here, the only thing you need to do, this will be a summary of once it's complete, of the auto detection sequence. It'll list in all the motor parameters here, the resistance, the inductance, the max velocity, inertia, and friction values. To find those values, go ahead and click the auto detect button. So this will move the motor, so make sure that everything is safe for motion. The first thing it'll do is it'll detect the Hall sensor. And it's found that. Next, it'll actually look for an encoder. It doesn't know that there's no encoder connected at the moment, so it'll look for one. And here it says that no encoder was detected. If you want to continue anyways, in this case, we'll click yes. And now it'll try to find the electrical parameters of the motor. This will be the back EMF, the resistance, the inductance. We'll go through this process twice to find the most accurate parameters. After this, we'll try to find the mechanical parameters. So this will be the friction values and the inertia value as well. It'll go through this process twice to find accurate values again. After this is done, everything is completed. So we can go ahead and click the close and click, and now you see all the parameters here are filled in with everything that was detected. You can click next, and you can save this file, these parameters to file if you would like. You can use them for future use. And now that we have everything detected, we'll go ahead and just do some quick motion here. Go to the test drive window. The first thing you want to do is enable the motor. In this case, since we're using such a low resolution feedback with the Hall sensor only, we actually want to have a pretty high gain, so we have a high control over that position. The easiest way to do that is to use one of these preset firmness values. So you have 1, 2, 3, 4, and 5. 1 is the lowest, so like kind of the loosest control on the feedback, and 5 is the highest. For this type of setup, I would recommend using a pretty high value. It'll give you kind of the smoothest motion as you start moving. So we'll go ahead and jog in the positive direction. This will be in about positive direction, and then we'll go in the negative direction as well. Move a little faster. And that's a quick demonstration on how to set up a servo motor using a Hall sensor feedback only.